Hi, my name is Brad Neal with the University of Indianapolis. We're going to talk about the heats of dissolution lab. First thing you need to do is get your styrofoam cup. Then you need to go get a burette stand. Make sure that you grab a ring clip to go along with that burette stand, because that's what we're going to eventually use to hook up our thermometer. Now, the thing we're going to use to hook up the thermometer is a paper clip or a piece of wire. If you get that paper clip, you're going to want to bend it like you see here so that you've got two hoops. You're going to use that hoop to eventually grab on here to your ring clamp or your ring stand. So it kind of hangs on the side here, a little bit like a Christmas ornament. Then grab that thermometer, and you're going to notice at the top of that thermometer, there should be a place for you to hang it on the paper clip. So grab that thermometer, drag it over, and hang it on that paper clip. Make sure that the bottom of the thermometer is below the solution that is inside your styrofoam cup. Make sure you know the mass for the quantitative part of the lab. Qualitative part of the lab, you don't need to know so much. So take your weigh boat and your stuff that's in your weigh boat, and you'll be able to add directly the stuff into your container. You'll be able to qualitatively then measure the temperature change. That's right, you're going to use your good old eyeball, the detector you always have with you, to determine that temperature change. So you'll be able to determine that change in temperature using the nice equation delta T equals temperature final minus temperature initial. Now let's talk about the components of part 2. You're going to be collecting the mass of your material. You're also going to be collecting the change in temperature of your reactions. Now, as an entire class, you're going to be generating a lot of data. So what you have is mass and change in temperature. What you want is moles per heat released. So as a class, you have lots of data, but how do you convert that mass into moles? Well, go back to your General Chemistry Chapter 4 material, and if you have the mass of a material and you know what that material is, you can use the molar mass of that material, so 1 mole magnesium sulfate over some amount of grams of magnesium sulfate, let you calculate that. You can figure out how many moles of magnesium sulfate you then have. So in an Excel file, you can actually set this up to calculate that for you. And then you have that information. But what about the Q? What about that heat that's changed? Here's the equation Q equals mc delta T. This is what we're going to use. We'll know the mass of the water that we're using. We know the specific heat of our water, and thanks to the Logger Pro software, we know our change in temperature. So we know the 3 things necessary in order to calculate Q. Now that we've got Q, it's now time to go ahead and start thinking, what can we do with this material? With this data. So we've got our moles per heat. Now we can graph it. Now if we put that Q on the y-axis and we put moles on our x-axis, something neat happens. We can plot out the equation y equals mx plus b. And m we know is our slope. Slope is equal to rise over run. And in this case, our rise is going to have the units of joules and our run will have the units of moles. Hey, that's pretty great. That gives us the information we want. Hope that helped.